Hi, I am R. Venkatesh, Assistant Professor in Electronics and Communication Engineering Department at Rohini College of Engineering and Technology, Anjigramam, Palkulam, Kanyakumari District. Now we are going to see a topic in optical communication system that preamplifier and its process. After the completion of this topic, student will be able to explain about the basic concept of optical preamplifiers and its types. Introduction. Preamplifier. In an digital receiver, preamplifiers are the front-end unit. The sensitivity and the bandwidth of receivers are dominated by the noise sources at the preamplifier stage. So here, the bandwidth, bit error rate, noise sensitivity of the optical receivers are determined by the help of preamplifier front-end unit. The preamplifiers are generally used in optical fiber communication receivers, and it is the basic structure is classified into three different categories. So one is low impedance preamplifier, high impedance preamplifier, and transimpedance preamplifier. The main advantages of the preamplifier is the preamplifier should satisfy the following if it satisfies the following requirements such as low noise level, high bandwidth, high dynamic range, high sensitivity, and high gain. A preamplifier should satisfy the following requirements, then it is used for the particular circuit. So first we are going to see about the low impedance preamplifier. The diagram which is represented below, in the low impedance front end optical fiber receiver with voltage amplifier. So here a photodiode operates into a low impedance amplifier and a bias or load resistor RB is used to match the amplifier impedance along voltage amplifier with an effective input resistance RA. RB along with the input capacitance of the amplifier decides the bandwidth of the amplifier unit. The preamplifier bandwidth is equal to or greater than the signal bandwidth. Then the total load resistance RTL is given by RTL is equal to RB into RA divided by RB plus RA. So the low impedance preamplifier can operate over a wide bandwidth, but they can poor receiver sensitivity. So they are used in special short distance applications where the higher sensitivity is not major concern. Next we are going to see the high impedance preamplifier. The problem which is noticed in the low impedance preamplifier should be overcome in the high impedance preamplifier. So to attain a large detector bias resistance RA is used to reduce the effect of the thermal noise which is arised in the low impedance preamplifier. The second configuration which consists high input impedance amplifier, the main goal is to reduce the all sources of the noise to be absolute minimum. This can be achieved by two different circuit unit. One is high impedance FET amplifier unit and another one is the high impedance bipolar transistor unit. By selecting the detector with low dark current and minimizing the thermal noise of the bias resistance, the high impedance which gives the large input RC time constant and the front end bandwidth is less than the signal bandwidth unit. So that the input signal is to integrated and equalization techniques must be employed to compensate for this signal. When we are to reduce the noise in the high impedance preamplifier unit, we have to we have to consider main goals to reduce the all source of the noise to be absolute minimum level. So by first point, reducing the input capacitance through the selection of low impedance, low capacitance, high frequency devices. Second, selecting the detector with low dark current. Third, minimizing the thermal noise of the bias resistor unit. So by using these three different points, we can reduce the noise in the high impedance preamplifier. Now we are going to see the Transmittance Pre-Amplifier. The Transmittance Pre-Amplifier is nothing but the low noise high impedance preamplifier with negative feedback resistor RF. The device therefore operates as a current node amplifier where the high input impedance is reduced by the negative feedback unit, and it comes the drawbacks of the high impedance amplifier such as for broadband applications equalization is required, limited dynamic range. So in the high impedance preamplifier, the transimpedance preamplifier is nothing but the low noise high impedance preamplifier with negative feedback resistance capital RF. The transimpedance preamplifier is designed to overcome the drawbacks of the high impedance amplifier unit. The equalizer output RB is expressed as RB dash is equal to RB into RF divided by RB plus RF. So the bandwidth of the transimpedance amplifier is capital A times that the high impedance amplifier. Because of this, the equalization becomes easy. The bandwidth of the transimpedance preamplifier is given by B Tz is equal to A divided by 4 into Rc, where the thermal noise characteristics WTz and the equalizer output can be found. The thermal noise characteristics are the sum of the output noise of a non-feedback amplifier pulse and the thermal noise associated with the feedback resistance. The advantages of transimpedance preamplifiers are it provide a wide dynamic range, little or no equalization is required, less sensitivity to pick up the noise, crosstalk, and electromagnetic interferences, and it is very easy to control and stable one, and it provide loss sensitivity and output resistance will be very small. Thank you.